Hello friends, welcome to my channel. Let's have a look at problem 2482, difference between ones and zeros in row and column. In this video, we are going to share two treatments. The first one actually is verbose, so this is routine because we just need to follow the problem requirement. But this method might be helpful to help us gain some feeling, intuition. And the second format is just use some simple analysis. And first, I'm going to read through the problem statement, and then we are going to write the code directly. So first, let's look at the problem statement. So we are given a zero-indexed m by n binary matrix. So notice that the matrix is binary matrix. So a zero-indexed m by n difference matrix diff is created with the following procedure, right? You count the number of ones in the ith row, so count the number of zeros in ith row, similarly count the number of ones and zeros in jth column, and then diff ij equals the ones in the ith row, the ones in the jth column, then minus the corresponding number of zeros. So our task is to return the difference matrix diff. So this problem actually is very routine. So basically, the purpose of this video is to practice the use of the zip function, right? So here is an example, right? So you can analyze the output according to the explanation. So here the constraint that's basically on the m and n, in other words, the number of rows and columns. So the total element is bounded above by 10 to the power 5, right? So here, let me emphasize again. So the matrix is a binary matrix. Okay. So with that said, let me first finish format 1, and then we want to simplify a little bit based on some simple algebra. So here V1 is a verbose one. So it just follows the problem statement. So first I'm going to call this m and n, the number of rows and number of columns, right? And then I'm going to compute the transpose of this matrix. So this is actually very simple to compute. Essentially, it's nothing but zip grid, right? So we actually pass this guy as a tuple, right? And then this is actually not a list, so let me make it a list. So I'm going to list atom for atom in this iterable. So with that transpose, let's see, transpose. So with that done, so what we are going to do is that, so we initialize a matrix. So this is what we are going to return, right? So the size, then for dummy index in range m. So this is very routine. So I'm going to compute the number of rows, and the row sum and the column sum, or the number of ones and zeros in each row and column. For that, let me use something like this, rows. So I'm going to use dictionary. So I'm going to compute the number of ones in this ith row. That is nothing but sum of grid I. And then the number of zeros is nothing but the row length minus the number of ones, because this matrix is a binary matrix. So actually it's minus grid sum grid I, right? So this is for I in range m. So similarly, we can compute the column number, column ones and zeros, right? So sum, so transpose I, and then so n minus this guy. Let me just directly copy this one. So this will be the number of zeros. Then for j in range m, right? So then we just need to fill the corresponding values in the result. So for this, let me do a while loop for I in range m, for j in range m. Then we're going to compute the result. I'll set this one. That is the number of rows. So if you look at this one, so it's just the the difference of ones and zero in the row, ith row, and the difference of ones and zero in jth column, right? So we just need to do this. So right, so rows I, so 0, this is the number of ones, minus rows I, so 1. Then plus so columns G. So here's G, it's the number of ones minus the columns G 1. So that's it. So we just need to return the final state of this result. So this V is sort of brute force. So let's do a check first. So for variable I, so for so here, yeah. So let's change this one to be J. Variable I, so for J here is still I. Now let's do a check. I, still I didn't get that. So okay. Variable I, so let's see why I. So here J, so yeah, it passes the first example. Now let's see the generic case. So it might be slow for this format of solution. So wrong answer. So what's the problem? So I, so rows I, J, J columns J0. So for J, so here, yeah. So here this should be M, right? So now let's do a check. So why the first example passes? Because the first example is a 3 by 3 matrix. So now let's do the check. Yeah, it passes all the test cases. So now with this verbose solution, so we know the logic. So now let me copy this part. Let's simplify it a little bit. So here I'm going to call this one V1. And now this one is V2. So for this V2, so we want to choose make some simple algebra, right? So here you can see, so the difference is count the number of ones, right, in the ith row, jth column, and minus number of zeros in ith row and jth column. So you know this is the number of ones. Then n minus number of ones, so this will be number of zeros, right? So similarly, we can do this for the column. So if you do some algebra, so you will see this is 2 times sum of row I minus this column, right, n. This is the fixed. So similarly here, so we get 2 times sum of jth column, so minus number of rows. So in total, this 2 times the row sum and j column sum, then minus m plus n. So then we just need to set like this, right? So here, let me m and n, let's keep it. So this is transpose, let's keep it. So this is the solution format. I'm going to keep it. And then I just need to know the column sum and the row sum and the column sum, right? So I'm going to do this, row sums. So I'm going to use a map. So I'm going to map the sum function to the grid. So this way I get the row sums. So column sums. So I'm going to use this one, sum, apply this function to each element in the transpose, right? Transpose. So I'm going to make this a list for the each of iteration. So, but you can choose not to do this. And then we're going to set this one, right? For I, for J. Then what we're going to do is nothing but 2 times row sums at index I. So this is the sum of the ith row plus column sums, so of jth column, then minus m plus n, right? So this part is always fixed, right? So then we just need to return the result. So this is the second version. So now let's look at the test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the test cases. So actually, as a set comment, you can further simplify the code to make it shorter. but that's not our purpose. So here we want to explain the logic. So with that said, actually that's about it for a solution to this problem itself. So in this video, we practiced two useful functions. So one is the zip function, right? So this zip function. Another, so maybe we can see the map function. So we apply a function to the atom in an iterable, right? So with that said, I guess that's about it for this video. Thank you.